Hello, everyone. We are algorithm and calibration team for Cisco at the data mine. Our group has two goals: improving the current stream selection method for demand forecasting of consumer electronics and software solutions, and improving that stream selection method by looking for outliers. We use Cisco's historic data to implement a variety of statistical models to better select streams. Each stream represents a different model. We are selecting the best stream as each stream takes an output of a unique model. Since the products we're looking at represent the full suite of Cisco products ranging from router hardware to IoT solutions, there is no perfect model for predicting all different types of products. That's where we're focusing on identifying which model best suits which types of products in order to best tailor forecasting.
Our first group worked to improve the stream selection. One of the statistical models we're trying to implement is the Bayesian model. It's a probabilistic classifier that utilizes known data values, for example, data traits such as price deviations and probabilities to correlate the aforementioned traits to a class, the different streams. Next, Gaussian mixture model is a clustering technique employed to cluster different PLIDs in three different components. It works by clustering PLIDs into different Gaussian distributions, which helps classify the data for detecting outliers and seasonality in the data. The maximum likelihood estimation is the process of placing a distribution curve to a set of data that maximizes the likelihood of observing the data that generate the distribution. We applied the maximum likelihood estimation to historical data streams outputs and selected the stream closest to the average. This was less robust to the initial conditions, so we will continue working mostly on the Bayesian model. The second team worked to detect anomalies, and we used three different methods. The standard deviation, which used normal standard deviation to look for outliers in Cisco's PLIDs. We first found the average, and then we measured how spread out the data was to the average. We set a threshold and decided that any point that lied outside of that threshold would be considered an outlier. Next, we use isolation force model to separate the anomalies within a dataset. It operates by splitting the difference between the predicted and the actual value to partition the data points until it's a single data point. An anomaly score is then calculated for each data point based on the number of splits required to isolate it. Lastly, we decided to replace the standard deviation model with a nonlinear support vector machine model, which finds a plane to separate the outlier PLIDs from the rest of the PLIDs. The model makes a curve instead of a straight line for finding the outliers.
In overall conclusion, across both of our subteams, we were able to achieve an overall noted improvement from the original baseline data provided by Cisco. Specifically, our enhancing algorithm team, which focused on standard deviations, did see an improvement. Provided we had more time, we would utilize hyperparameter tuning to enhance the output of our model and better calibrate both our data processing and the data models themselves to be more accurate and to provide a better comparison against Cisco's current system.